Hello everyone, welcome to the live class. So guys, today we are going to have another very important session and we are going to discuss the important concepts and the questions of classical mechanics in today's session. So I hope each and everything which we are going to discuss in this session will get clear to all of you. And at any point of time, if you will have any doubt anywhere, you will just let me know about it. We will consider all those points and we will do the discussion about those things. And even I'm just going to check your comments along with the discussion. Clear? So I hope audio, video and everything is fine till now. Please let me know once in the comments and then we will start the discussion. Is everything all right? All good? Okay, that's good. So that means we can start the discussion now. And if you will have any doubt anywhere, you just need to mention it in the comments and we'll consider it. So in today's session, I'm going to consider different situation based questions. Okay, basically they are going to be the different concepts or the system based discussion which we will do in today's session from the classical mechanics. It's somewhere related to Lagrangian as well as other topics we will try to consider. So let's quickly start the discussion. I'm going to show you the first condition or first system based on which we will do the question. Okay, so basically I have not mentioned it as a question here, but I have mentioned it as a system, the complete system. Okay, so the first one is from the Lagrangian dynamics. And here we are considering a simple pendulum. After simple pendulum, we'll talk about many spring mass system. Clear? So where the systems are going to have different way of connections. How the mass have been connected to the block, okay, to the spring basically. So different things we will consider in today's session, which will make the understanding with the topic more clear to you. And you will be able to solve any such system based questions easily in your exam, because they are going to have the great chances that one question from different type of systems you can expect. Okay, so let's start with this one. And here firstly I'm going to tell you some of the points about it, and if you will have any doubt, any question, any query about this one, you will let me know and we will do the discussion about it. Okay, so let's start the discussion. So guys, if we are going to talk about Lagrangian dynamics, we all know that Lagrangian dynamics, that's gonna be related to, okay, just Lagrangian, which is T minus V, which is kinetic energy minus potential energy. Based on Lagrangian, there are great chances that you will get the questions sometimes in which you just need to find the Lagrangian itself. Sometimes they will give you a system and you need to find the Lagrangian from there. Okay. Sometimes they can ask you some information about the given system, like they can ask you to find a particular height or a velocity, okay, at any particular point, or any information about the system they can ask you to find. So in that case, the Lagrange's equation of motion will help you. Clear? If you want any information about the system, then the Lagrange's equation of motion will help you. Now the first system which I am going to consider here, that's gonna be a simple pendulum. Okay? When we are talking about a simple pendulum, in some of the books you may get a difference there. What is that difference? I will even let you know about it. So first of all, this is our simple pendulum's equilibrium position. Okay, but when it has moved to like just by an angle theta, and this is gonna be at this particular point, when you are going to observe it in some of the books, they will consider like, okay, this will be at some upper point and this distance will be somewhere here. So they are going to consider only this much distance. But right now what we are doing, we are considering it like just a small angle theta, due to which we will consider that this length and this one both will be same. Okay, so that can be a difference you can get somewhere, okay, in some of the books. So here don't get confused with the length part, that only this much has been considered, but at some of the places you can get the complete length, that's gonna be total minus this one. Okay, in that way even they can give you. Now if we are going to talk about the steps we will consider to get the Lagrangian for this system or Lagrange's equation of motion. So what are going to be the steps? Let's consider them. And the first point I have cleared you. Okay, don't get confused at that point. It will be as per the situation. If they are saying the theta is the small, you can consider them almost equal, and that's what I'm going to do right now. Clear? So if I'm going to talk about the degrees of freedom about the system, that's gonna be only one. Why? How many independent coordinates we are having which can freely change? Okay, so only one, that is theta, because length is a fixed length here, so only theta can get changed, due to which the degrees of freedom is gonna be 1. Okay, now the next point. Here, to define the system, we only need two coordinates. What are these two coordinates? One is the length of the string, another one is the angle. Clear? That at what distance the pendulum is right now, and that we can measure with this angle theta. Okay, so in this case what will happen, the plane polar coordinate system is the best suitable coordinate system for this particular system. Okay, so that's why we are trying to write the x and the y axis in the plane polar coordinate system, the x and the y coordinates. So when I'm considering this height, okay, so what will be this height? If this is the angle theta, it will be L cos theta, and we are considering it is below origin. That means we will have the negative y. Okay, next thing, if I am going to consider the x-axis distance, that will be L sin theta. Okay, now let's talk about the further steps which we will take to get the potential energy and the kinetic energy expressions. So if I am going to talk about x, that is L sin theta, y minus L cos theta. Why? Because it's below origin. Okay, that's why that's gonna have the negative y value. After this, if we are going to talk about x dot, that is dx by dt, which we need to find the kinetic energy expression. So that will be L cos theta theta dot. Why? Because we are just going to have the theta which can vary with time, but the length of the string we are considering fixed length. So that's why we are not differentiating L here, or even if you will differentiate it, you will get 0. Okay, with respect to time. Similarly, if you are going to talk about y, so y dot will be L sin theta theta dot. Okay, anywhere if anybody is going to have any doubt, you can mention it and we will consider that point too. Now after this, when we are going to talk about the potential energy, because if we are going to talk about the potential energy, why we need it? Okay, because we know L is equal to T minus V, so potential energy has been considered here, and to write the kinetic energy we need the velocity. Okay, so velocity, how we can consider it? Because two coordinates we are considering x and y, so velocity in general will be x dot and y dot. So for both the components we have to write the velocity. Now the point is, in our kinetic energy expression we are going to have half mv square. So I will directly write the v square, which will be x dot square plus y dot square. Clear? So in this case what will happen? X dot square plus y dot square, when you will consider, you are directly going to get L square theta dot square, which means it is the velocity expression in the plane polar coordinate system which you will get. Clear? But there is one more term, that is r dot square. Okay, and we are not considering it here. Why? Because r is equal to L, which is fixed, so r dot is 0. That's why that term has not been considered here. Clear? Next thing, if we are going to talk about the kinetic energy expression, what will be the kinetic energy expression now? That's gonna be half m L square theta dot square. You will just put it in the kinetic energy formula, which is half mv square. Done. Next thing, if I'm going to talk about the potential energy expression, that is going to be mgh, height, that is minus L cos theta. Okay, because it is below origin. This is origin we are considering here. Clear? So it is below origin, and due to which minus L cos theta will be the height. So we are going to get minus mgl cos theta. Done. Now we know that Lagrangian is T minus V, which means kinetic energy minus potential energy. So just put the values, you will get this particular expression. After this, you can write the equation of motion, okay, which is, now the point is, I'm going to ask you one question. How many equations of motion you can write for this system, and for which of the coordinates? You just need to mention it in the comments and let me know. Shobna, I will repeat it. And how many equations of motion you can write? You just need to mention it in the comments once. Shobna, L cos theta and L sin theta, how we have considered? See, if this is origin, okay, and this is the angle theta, so with which axis the angle has been made? With the y-axis, okay. And what is the length of the string? That is L, okay. So this is the length of the string, which is L. Now the point is, this component, the vertical component with which the theta angle has been made, what will be that component? It's gonna be L cos theta, okay. And if we are going to talk about the x-axis, that means this particular component, which is normal component for the theta angle. Okay, it's not along with that particular axis, but it's like on the other side. So it will be L sin theta. So normal components we are considering here. Okay, that's how we have written it. And the first point, the first value we write for the x coordinate, and the second one we write for the y. So x comma y we have mentioned. And since here we are considering origin, so the lower length will be negative, or the y values we consider negative, okay, below origin. So that's what we have done. Okay, that's very good, guys. Most of you have mentioned just one, and some of you have even mentioned two, but it's just gonna be one equation of motion, okay. Why? Because L is fixed. So if you are going to write it for L, what will happen in that case? You will not get this term in the equation of motion. If you want, you can write it. Generally, if you are going to have the variable length, that means, let's say it's a spring connected here. Instead of a string, if it is a spring, okay, spring length can vary. So when spring length can vary, and let's say we are considering it R in general, so we can write the R and theta coordinates then, okay. Now the point is, here, since only theta is going to get vary, so we are writing or considering the equation of motion in terms of theta. The formula will remain same. If you need it somewhere, if you want to find it somewhere, you can even write for R, but mostly there are chances that you will get only for theta, okay. So that's what we have mentioned. D by dt del L over del theta dot minus del L over del theta equal to 0. Here we have written the equation of motion for theta, okay. Now let's have a look at this, that further what we will get. It's here. See, when you are going to differentiate it, also be careful. It is the partial differentiation, which is del L over del theta dot. This is the partial differentiation. Only you will differentiate the theta dot for this one, okay, where theta dot you are having at this place. So only it will differentiate this term, and after that do its normal ordinary differentiation with respect to time. So that's how you will do it. And del L over del theta will consider this term, because that's again a partial differentiation, so you will not differentiate this term, only differentiate this one, okay. That's how you will consider it. Now after differentiating, see what you are going to get. This is gonna be the expression which you will get. Please take it once and let me know if there is any doubt anybody is going to have in any of the expressions till this point. This is final equation of motion you should get. But if there is any doubt anybody is having in getting this equation of motion, you can mention it. And such type of questions you can get in the exam, that they will just say in the statement form, okay, that there is a spring, just a simple pendulum, and you need to find the equation of motion for that. Even I'm going to include many other points along with this discussion, so you just need to tell me whether you are getting exactly same or something different, okay, or if there is any doubt anywhere, you just need to mention it. We'll consider that too. Is it okay and clear till this point? That's good, good, good. Very good, very good. Any doubt, any doubt? If yes, please let me know. If no, that's good. We can continue the discussion then. Clear? And it's very important for everyone to understand or to know about these systems, okay? Because once you will get the idea about these things, you will easily be able to solve any such system. Done? No doubt? Let's continue the discussion then. Okay, so guys, basically after this, since we are considering this small oscillation, okay, that means we are considering theta is small. So once you are going to apply this condition that theta is small, theta is tending to 0, now what will happen? We know the condition regarding the sine, that is sine theta will be approximately equal to theta, and also this condition is very, very, very important, okay? Don't miss it, because somewhere, anywhere even, in any of the subjects, in any of the questions or expressions, you may need the expression related to sine theta. So whenever theta is small, you can write sine theta, as we have mentioned it here right now. And after that, when you are going to replace sine theta with theta itself, this is the equation you will get after taking the m common from this expression. You have got this, but now when you are going to put the condition that theta is small, you are going to get this particular expression. Now after this, what we are going to do, because the general expression which you are going to have for the equation of motion, in that expression you will have this term as omega square, okay, this term as omega square. So if it is equal to omega square, what will be the value of omega? So that will be root g by L, okay, and along with that, the t, time period is what? Time period is 2 pi by omega. T is equal to what? 2 pi by omega. So once you are going to put the omega value here, you will get 2 pi root L upon g, okay. So that's how you are going to get your final expression. Now the questions from this topic, you can expect that they can ask you to find the angular frequency, they can ask you to find the time period, they can ask you to find the equation of motion, okay, or any of the expressions which we have considered, the final results we have got, okay. Based on them, you can expect the questions in your exam. If there is any doubt anybody is having, please let me know, and if it is clear, we will talk about the next system now. So let me know whether it is clear or not, and if yes, then here is your next system, which is gonna be a spring pendulum, okay. It can be given like this or it can be given like this as well. So let me know if there will be any doubt anywhere anybody will have. Done? Okay, so now let's talk about the spring pendulum. If we are going to talk about it, what will happen in this case? See, spring pendulum, now that string, okay, has been replaced with spring, that means its length can vary, okay, and a block of mass m has been connected here. It can be shown like this or it can be shown like this, clear? So any of the diagram, whatever has been given to you, you can consider them a system that is known as a spring pendulum, okay. Now next point, here the spring which we have considered, its spring constant we are considering as K. So K is what? That is the spring constant of this particular spring, and the block's mass is m, okay. That's how we are going to consider it. Now to solve any such question, most of the times what happen, students are going to have some fear about such type of questions, and they consider like, oh, if they are getting a new system, a question based on a new system where the spring is present or any other thing is present, they are going to have a fear that they can't solve it because it's new. Guys, you can solve any new system based question as well if you know about the things present in that particular system. So don't worry about it. And to get that confidence, what you can do, you can practice some easy systems initially, okay? Then step by step try to increase your level, and that's how you will be able to have that confidence that whatever system is there, you will be able to solve such type of questions easily. Done? Clear? Now, let's consider the next point. That's gonna be the degrees of freedom. Again, in this case, now since it is a spring pendulum, we are considering its motion, like let's say it is a spring, okay? And here is the mass connected. So we are considering it can just move like this. That means now the variation will be in R, okay? In the value of R. R means the length of the spring, okay? Now, if we are going to consider the kinetic energy in this case, what is that? That is half mx dot square, half mx dot square. If I am considering this variation along the x-axis as shown in the first figure, then I will consider it as half mx dot square. Same thing, if it has been shown or it has been mentioned in the question that the variation is going to be along the y-axis, you can replace this x with y and you can write the expression for that too. Done? So now, if we are going to talk about the potential energy expression, we all should know some general formulae like the potential energy is stored in the spring. So what is the potential energy expression? Half kx square. Okay, half kx square, the potential energy corresponding to spring, and half mx dot square, that is just normal kinetic energy. Next thing, if we are going to talk about Lagrangian, then in that case normally you can write half mx dot square minus half kx square. That's going to be the Lagrangian expression you will get. After this, the equation of motion, only one thing is going to get varied, that's x. So what you will do, you just need to write the equation of motion in terms of x, and that's how you are just going to get the final equation of motion in this form, that is mx double dot minus kx is equal to 0. Now from here you need to do one thing. You need to finalize the expression of omega for this type of system. Okay, I'm even going to show you the previous case and you just need to finalize it, that what will be the value of omega. See, when this was the expression, you have got it. Clear? It's positive sign in between you have got, and this was the omega expression, which is at this place you were getting G by L. In the same way, you just need to check for this one. Also guys, be careful about one thing, that here you are going to have a plus sign. If you will check the expression, okay, negative and negative will become positive. So here you will have a plus sign. Now you can finalize the omega value. Shaboni, that's gonna be same if you are considering it corresponding to spring. So this is the fixed potential energy expression. Okay. Guys, let me know, did you get the omega value? And if yes, you can mention it in the comments. Okay, Renu has mentioned. Renu, do you want to consider the square root along with that? Because it's gonna be x double dot plus omega square. Okay. So you will get k by root k by m there and x. Very good, Kirti. Very good, Renu. But you just need to consider the square root in before writing the k by m. Very good, Sunil. Very good, Shaboni. What about others, guys? If you are having any doubt anywhere, you can let me know. So once you are reaching to the equation of motion, now it's going to be simple and easy for you to write the omega value. Very good, Bhagya. Very good, Anirban. Very good, Smriti. Very good, Sudeep. That's very good. Almost everybody's answer is correct. Very good, Shravan. Very good, Kishan. Very good, Kajal. And very good, everyone. Your answers are correct. Okay. So what will be omega? That's gonna be root k by m. Clear? If there is any doubt anybody is having, you can mention it. You can let me know about it. And we will consider that point. You can have a look at this. It's root k by m, and the time period if you want to find, that will be t is equal to 2 pi by omega, which means the omega value you can put there and you will get this expression. Okay, next system is here. Please consider it and let me know if there is any doubt anybody is going to have. Yes, Subramanyam. But right now we have considered the variation along the x-axis. Okay, if you will look at the expression, so we have written it just for the x-axis. So that means we are not just going to consider it in this form like this, but we are considering it like this. So the first diagram we have considered in the previous case. Okay. Kirti, we will consider that point too. Guys, have a look at this and let me know whether there is any doubt anybody is having or not. Kirti has mentioned one point. I will talk about it, but what about others? In the same way, this is just a modified form. Okay, in the previous case we have only considered this much part. Okay, only this much, nothing was there, it was not connected even. But now we are considering 2 blocks and 3 springs having the spring constant k. So you just need to tell me whether this system is clear or not. The expressions you can see right now. If there is any doubt anybody will have, you just need to tell me about it. Okay, Kirti, let me know for one particular block, what will be the degrees of freedom? What will be the degrees of freedom for one block? Like you can see there are 2 blocks, 1 and 2. Okay. So you need to consider what will be the degrees of freedom for one block only, because it can move either along this side or this side. So only it can move like this, okay, like this. Either it will go this side or this side. Similarly, this one is free to move along this and this side. So what is the degrees of freedom for the first block? Firstly, we will consider that. It's 1. Very good, everyone. And 1 for this. So what will be the degrees of freedom for the total system? 1 for first block, 1 for second block. What about the total system degrees of freedom? That will be 2, because you are considering for the complete system there. Okay, is that clear now? Done? 1 for this, 1 for this. For total system, it's 2. Only they can move like this. Done? That's good. Let me know if there is any other point which is not clear to you. Very good, Shavana. Any other point where you are having any doubt? Clear? Is it clear? And the variation when you are considering now, so one is moving on the other side. Let's say we are saying the distance covered by the first block is x1 and the second block is x2. So what is the resultant distance covered from their equilibrium position? Okay, so different conditions have been considered. Let's say only for this one, and the resultant term. Okay, that both are moving towards each other, both are moving like this. Okay, so that's how you can have a situation, and every situation has been considered here. Kishan, corresponding changes will be there because you are putting one more restriction, and when you are going to consider it, then different situations can be there, whether you are going to move it towards that side or not. Okay, so then it's gonna have more restriction and the things will get changed. Everything will get changed. Even this term you have to be careful about it. Clear? I'm going to show you the next slide and you will let me know if there is any other doubt anybody will have. It's here. Samayajit, today at 4 p.m, tomorrow at 4 p.m, day after tomorrow at 4 p.m, that means Monday, Tuesday and Wednesday at 4 o'clock, we will have these sessions. If anywhere anybody will have any doubt in any of the steps, even the plus minus sign, okay, after writing the complete Lagrangian expression or Lagrange's equation of motion, so you need to check it once and tell me if it is not clear, if you are finding like, oh, it should be something else. So let me know about it. We'll do the discussion about those points. Renu, let me know once it will get clear. Shweta, I will consider. Second step on the next slide now. Shaboni, Unacademy Plus courses classes are also going on. Okay, and about the spatial classes, you will get the information about it in the description box of this video. Even you will have the spatial classes link. Smriti, it is just dependent on the variation. Let's say one spring is moving in this direction and the other is moving in that direction, the opposite direction. So one you are taking positive, another one you are taking negative. Okay, if it is moving in the other direction. So that's how you are going to get the second term. Clear? One thing you are considering when it is moving in this direction and it is also moving in this direction. So from the equilibrium position, it has covered a distance x1. It has also covered a distance x2. Okay, so what will be the total energy for this type of motion? So it will give you two terms, kx1 square and kx2 square. But when you are going to consider their motion not exactly in the same direction, okay, when they are not moving in the same direction, you are applying some external force and you are going to make their motion in such a way, one is moving this side, another one is moving this side. So that's how you will get a term like this. Done? Is this slide clear to everyone? This slide clear? Here's the next one. Please let me know if there is any doubt. Also guys, one more thing. Now you are having two variables, two like degrees of freedom, and you are having two terms present which are going to vary. Okay, x1 and x2. So overall, if I'm going to talk about the equation of motion, you will write it for x1 as well as you can write it for x2. Okay, so for both you will try to consider it. So it's gonna be for the x1 we have written the first equation of motion, then second one for x2. And anytime if you are going to have more than one generalized coordinates, okay, which are going to get vary, you can write the equation of motion for them. So that's how we have considered. Is it clear? And if there is any doubt anywhere, okay, in any of the steps or anywhere, you can mention it, we'll consider that point. Is it clear? Smriti, let's say if they have not mentioned anything, then you have to consider all the cases. Also, you can do one more thing, that is you can get an idea from the options given to you that what type of expression they want you to find, okay, or what they have considered. Because sometimes if you are not getting exact idea from the question itself, we can get an idea from the options too. Okay, so you can take this approach, or otherwise they will mention everything in the question statement itself, so you will not have any kind of doubt. Done, clear? Can I show you the next system? If this one is clear, we can talk about the next system. See, what is the difference? If you will consider the angular frequency for x1 and x2, for this case it's different, for this one it's different. Okay, so for both it's just going to get exchange for x1 and x2. Here is going to be the next slide. That's good. Guys, next system. When two blocks are connected with a spring in this way. Now again, since all are related to each other, okay, so we are just going to go through them quickly to get an idea that exactly what we need to consider. Okay, if you will have any doubt anywhere in any of the steps in these points, you can tell me about it. And if it is clear, that's good. The first point is degrees of freedom. How? Because both the blocks are there, both can move. It can cover a distance from the equilibrium point, it can cover some distance from the equilibrium point. So that's how the degrees of freedom for the complete system will be 2. And we are considering x1 and x2 as the variations from their mean or the equilibrium position. Clear? Now the total kinetic energy, it's going to be this one. If we are going to talk about V, okay, in this case, if motion will be there, can they move like together? No, we are considering the motion can be like this. Okay, again, it's a situation that one is moving in this direction, another one is increasing the length, other one is moving towards the origin. Okay, again the opposite direction. Okay, in the previous case when I was saying one is moving this side, another one is moving this side, it was increasing the length. Okay, from the origin it was moving away and it was moving towards the origin. So that's why we have considered the opposite sign. But right now, even if we will consider the motion like this and like this, so what will happen in that case? Because they are not connected from the corners, so they will move like this. So again, one is moving towards the origin, other one will move away from the origin, and that's how you are going to have this term in the potential energy expression. Okay, Shweta, one for the first block, one for the second block. Dekhiye, if we are talking about the complete system, okay, this block can move in this particular direction or this block can move in this particular direction. That means some distance they will cover. They are free to move. This one is free to move along the x-axis. This one is free to move along the x-axis. Now the point is, what is the degrees of freedom for this one? 1. What is the degrees of freedom for this one? That's to 1. So in this case, the total degrees of freedom for this complete system will be 2. Okay, and the distance covered by the equilibrium position, you are considering x1 and x2 for both the blocks or the masses separately. Okay, so that's how we have considered it. Shaboni, since overall square is there, that term will not change the potential expression. If you are writing x2 minus x1 whole square or you are writing x1 minus x2 whole square, overall thing is gonna remain same. Arundhati, they can come back, but that is the same case, na? In the same situation, in the same case, they are going to move back like this, so it's just the same situation. Right, Uday, that's correct. Is it clear? Is this slide clear? And if there is any doubt, you just need to mention it once. We'll consider that point too. Done? Is it clear? Arundhati, it's just gonna be that you can find the degrees of freedom as per that in how many dimensions or directions one particular system is free to move. Okay, that's like the direct way of finding the degrees of freedom. Done? Is this slide clear to everyone? No, Abrar, it's not tough. It's just you need to revise and practice these type of systems. Okay, if you're doing it after a long time or you have not solved such type of questions, you just need to practice them. Even after the session, consider. You can compare the conditions too. Like we have considered the different systems. So you can do one thing, you can compare the first one with the second and the third one. That, oh, this expression we have written, so how we are going to write it, how we are going to consider it. If you will start comparing, you will get the idea, like clear idea about all the things. Okay, a little bit analysis can help you to understand and to get that approach that how we are just writing the complete expression for the given system. Uday, for further questions even we will consider it. Is this clear? Clear? And guys, if you are finding something difficult, just devote some time on that thing, and after that it should get clear. If still it's not getting clear, that means you just need to change the way you are considering it. There is nothing like difficult, everything is going to be quite easy, okay, but it just depends how we are considering it. Abrar, if you are going to focus on studies whenever you are going to study, okay, then in that case, even in a day, just 3-4 hours will be enough. But that depends that how you are preparing the topics and how you are considering them. Smriti, right now we are just considering this, the potential energy expression for the spring. Okay, and that's gonna be the fix, but still if you want you can go through the 11th-12th concepts too. Okay, otherwise it's just the one concept we have used till now. Okay, let's talk about the last part. Let me know, are you talking about this one, the last part related to the equation of motion, this one? Thank you so much, Abrar. Are you talking about this last part or this one? See guys, I'm going to talk about the equation of motion. Okay, I think somebody is going to have some doubt in this part because this is going to be the last part. Or in the above expression, we have just written the kinetic energy for both the blocks, where we have considered the x1 distance covered by m1 mass block and x2 distance covered by the m2 mass block. Okay, so this is going to be kinetic energy expression where we have taken the sum of kinetic energies for both the blocks. Okay, second thing, we have talked about the potential energy expression. Since the spring is present here, so you will not use mgh. Mgh is basically when some object is going to fall, it's going to cover some height, okay, for that. But for the spring case, the potential energy expression is fixed, that is half kx square, where x is the displacement, okay, or the distance covered, sometimes you can say. In that case, for this complete system, since two blocks are connected, we will consider their motion in this particular way. Okay, and that's how you will get the complete expression as x1 minus x2. Basically, when we are considering x1 minus x2, we are considering that one is moving in one particular direction, other one is moving in the opposite direction. Okay, so if one is increasing the distance or the length covered, okay, the other one is decreasing it in with respect to origin. Okay, so that's how this expression has been considered. Then a minus b whole square is a square plus b square minus 2ab. That's what we have considered here. After this, Lagrangian is what? t minus v. So t is this expression, minus v is this expression. So you have got this half m1 x1 dot square plus half m2 x2 dot square minus half kx1 square minus half kx2 square, and minus minus will become plus. So that term you are getting. That's correct. Okay, next thing, if we are going to talk about the equation of motion, here again we can write the equation of motion for x1 and x2 separately. So what I have done, firstly I have mentioned for x1, which is gonna be d by dt del L over del x1 dot minus del L over del x1 is equal to 0. So in this case what will happen? Again, since it is partial differentiation, when you will differentiate it with respect to x1 dot, you will get one term from here, okay, only from here. So you will get m x1 dot, okay, when you are going to differentiate it with respect to x1 dot itself, because you will get 2x1 dot, 2 will get cancelled out, and this is what you are going to get with m1. So m1 x1 dot, okay, so that's what we will write here, m1 x1 dot. Okay, next thing, if I'm going to talk about the next thing, again I need to differentiate it with respect to time. So we'll get m1 x1 double dot. That's what we have written here. Done. For the second term, del L over del x1, you will get a term from here and here. Done. Del L over del x1. So you will get kx1 from here and you will get kx2 from there. And that's gonna be this one, kx1 will be positive because negative sign in this formula and negative sign in this expression, so it will make it positive, which is gonna be plus kx1 minus kx2 equal to 0. Okay, next thing, if we are just going to take m1 common from here, what will happen? You are just going to get k upon m1 and x1 minus x2, okay, equal to 0. So that's gonna be your final equation of motion which you are going to get. If we are going to talk about, I hope till this point everything is clear to everyone, but still if there is any doubt, you will let me know. And check it once that if you are going to find the equation of motion for x2, are you getting it exactly same as I have mentioned it here? Please check it once and let me know. You just need to proceed in the same way as we have found the equation of motion for x1. In the same way, find it for x2 and let me know whether it is exactly same or not. Kirti, let's say here is a block, clear, it is moving, let me just consider it. This is a block, it is moving x1 distance from the equilibrium position. It is moving x2 distance from the equilibrium position. Okay, now the point is for this one, half kx1 square plus half kx2 square, because both were increasing their distance with respect to origin. Okay, the equilibrium point, अगर इसके लिए हम इसको मान ले तो इसने भी increase किया distance को, इसने भी increase किया, ठीक है. Now if we are considering this condition कि ये जो है ना, ये इधर जा रहा है और ये इधर जा रहा है, या two things you are considering, and you are considering like this is moving. Firstly I have considered this and this direction, okay, and this is moving in this direction. तो again इसकी जो ये origin के respect में क्या हो रहा है, distance decrease हो रही है एक तरह से, ठीक है, और इसके लिए increase हो रही है with respect to origin. So again in the last two cases you are going to consider minus sign in between, and first one when both are increasing, positive. I hope now it will be clear. Okay, and still if there is any doubt you can tell me about it. Is it clear to everyone? Done? That's good, good, good. Let's talk about the next one, next point. So दोनों की इंक्रीज होगी तो आपने पॉजिटिव लेकर वो जो हमने नॉर्मल एक्सप्रेशंस यहाँ लिखे हैं ना, देखिए इससे कंपेयर कर सकते हैं. दैट्स व्हाट आई वाज आस्किंग यू टू एनालाइज इट, क्लियर. और यहाँ आप उसकी रिजल्टेंट ले रहे हैं. Here you are considering the resultant one. That's why the overall square is there. Okay, and here you have considered that condition and you have written the separate potential energy stored in the like spring or corresponding to those systems. जो पहला टर्म है वो इसके लिए है, जो दूसरा टर्म है वो इसके लिए है, और जो तीसरा टर्म है मतलब this one, second one, it will be for this system. ठीक है, तो देखिए again let's compare them as I have asked you to compare. Okay, let's compare. For this system, only this system, we had it in the previous case. Potential energy, only half kx square for this system. Done? This system and this system, they are similar. So you have written their potential energy, this one. But anytime, still if you are having any confusion or anything like that, consider it. If this type of system you are having, then in that case, you will have this term. ठीक है? इस बीच वाले सिस्टम के लिए ये वाला टर्म है, इसके लिए ये वाला टर्म है, इसके लिए ये वाला टर्म है. अब देखिए नेक्स्ट, ये सिस्टम कौन सा है? बीच वाले के जैसा है ना, जैसा वी हैड द इन द प्रीवियस केस. सो ये वाला टर्म है. तो जब भी ऐसा कुछ आपको सिस्टम में मिल जाए, आप सीधे इसको यूज कर सकते हैं. द ओवरऑल स्क्वायर यू हैव टू कंसीडर and the term should be like this. Is it clear now? And that's what I was asking you to observe and analyze. Okay, so when you will devote time on some topic, you are going to get it exactly like, oh, this is the thing I'm going to get. This is exactly what is happening. Is it clear now? Done? Kishan, right? That will be right. That will be like, that is a correct point. Done? So directly now for that type of system, you can directly consider it. Have a look at this and let me know whether you are getting some more idea from this one or not. If there will be any doubt, you can just tell me about it. We'll try to consider that particular point. Okay, so some concepts you are going to learn in such a way that, oh, okay, if it is in this way, I just need to consider this particular formula, and this thing can help you to save your time and to get the exact idea about it. Clear? Let me know once it will get clear, or if there is any doubt. So almost, if you are going to get the question, almost all the type of spring mass system we have considered here. Okay, and once you will get these systems clearly, even if they will make any changes, they will give you some other thing, you can just solve them. Okay, because you are having many ideas about the various systems. If any doubt anybody will have, you can tell me about it. Excuse me. Clear. Only one block is there now, and the springs, and they are connected, they are just bound to the walls, both the sides. Arundhati, in this case, you just need to consider that in how many directions or in how many ways this block can move. So only in one way. Either it can go this side or it can go this side. It cannot go any other side. Only this type of motion we are considering. So it is moving about the x-axis only. It can't move about any other direction. So the degrees of freedom will be 1. Okay, so in how many ways it can move or in how many directions it is free to move, that is going to tell you about the degrees of freedom. Kirti, basically you will consider it for the block. Motion किसका ले रहे हैं हम? Spring तो compress हो रहा है, ठीक है, या stretch हो रहा है. So it is just providing some extra length or just compression will be there. But the point is movement किसका हो रहा है? इस block का, ठीक है. So that is just the functioning of the spring. Guys, see, T, V and negative sign, L is equal to T minus V, and negative sign, L is equal to T minus V, and negative sign, and here it's gonna be positive. This one is correct, but they have made the negative. Done? Smriti? No. Smriti? I think that will make the things more clear to you, which we have considered. If two blocks are connected together with a spring, then you will write x1 minus x2 or x2 minus x1. I have shown by comparing the different systems. Okay, so that's gonna provide you a more clear idea. Consider that. Okay, instead of considering the direction or the motion, otherwise there will be many conditions or cases you may get confused, so don't consider it in that way. Okay, as I have shown you by comparing the systems, that will work very well for you. Done? No doubt, everything is clear. In this slide, please observe it and let me know. And also the angular frequency for this case, because only 1 degree of freedom is there, you can directly write that will be root 2k by m, and you can see that for this type of system the angular frequency is not root k by m. Now see what will happen. What is a possibility? Basically they can give you a question, okay, and they will give you this system there, and then they are going to ask you what is gonna be the angular frequency for the given system. Now we know the basic angular frequency expression for the system, that is root k by m. हमें पता है कि स्प्रिंग मास सिस्टम के लिए कहीं ना कहीं रूट k by m एंगुलर फ्रीक्वेंसी होती है ना, और वो बहुत फेमस एक्सप्रेशन और फॉर्मूला है, तो हम बहुत कॉन्फिडेंट भी होते हैं. इन द ऑप्शंस यू आर गोइंग टू हैव दैट रूट k by m. If with that full confidence you are just going to tick that, for this type of system your answer may get wrong. Okay, so be careful about it. ऐसे ही नहीं, कोई भी स्प्रिंग मास सिस्टम के लिए सिर्फ रूट k by m नहीं होगी एंगुलर फ्रीक्वेंसी. आप इस प्रोसेस के थ्रू उसको फाइंड कर सकते हैं कि क्या होगी एग्जैक्ट एंगुलर फ्रीक्वेंसी एक्सप्रेशन. ओके, एंड दैट्स हाउ इट इज गोना बी हेल्पफुल फॉर यू. इज इट क्लियर नाउ? क्लियर? सो ऐसे ही बस कि ऑप्शंस में रूट k by m है और वो बहुत फेमस एक्सप्रेशन है और हमने बहुत बार पढ़ा भी हुआ है, तो वही सही होगा. कई बार ऐसा होता है दैट वी आर गोइंग टू बी इन दैट मच कॉन्फिडेंस एंड वी विल टिक लाइक अ करेक्ट आंसर इज गोना बी दैट वन, बट डोंट डू इट because your answer may get wrong if you will directly apply it. Clear? So guys, this was the discussion for today's session. There are many other points in tomorrow's 4 p.m. session which is gonna be here. Okay, and day after tomorrow even we will have a session here, so we'll consider some more points. There are many other topics which we will consider in tomorrow and day after tomorrow session. So that's how we are going to have the discussion. And thank you so much everyone for joining this session. I hope each and everything, whatever points we have discussed in today's session, that will be clear to all of you. And at the end, I'm just going to provide you some information about the Unacademy Plus courses. As you all know, there are so many Unacademy Plus courses going on Unacademy Plus for your upcoming CSIR Net Physics exam preparation. So if you want to attend the more regular live classes by all the top educators we are having on Unacademy Plus for your upcoming exam preparation, then you can take Unacademy Plus subscription. Okay, and wherever you will take the Unacademy Plus subscription by using and by applying the referral code, that is Anjali Arora. As you can see, it has been mentioned here, no space in between, spelling should be same. That's how you need to write it, apply it, and get the 10% discount in the total Unacademy Plus subscription amount. Also, after taking the Unacademy Plus subscription, you will get so many benefits, like weekly quizzes will be there, doubt clearing sessions will be there, mock test will be there, okay, PDF of important notes will be available to you. So that's how you will be able to do the best preparation for your upcoming CSIR Net Physics exam. Also guys, let's say anybody is going to take the Unacademy Plus subscription right now and any courses already going on. Okay, upcoming courses will even be there, but any courses already going on. So what will happen, if you have missed any of the classes of that course, you will get the recordings of those classes and you will be able to cover up each and every part, okay, each and every session which you have missed. So in this way you will be able to cover up each and everything. Also one more thing, if you are going to take the Unacademy Plus subscription, for the part A there are separate courses going on, so you will be able to prepare for the part A too. Okay, after taking the subscription you will be able to attend the live classes for the part A as well as for your subject. Okay, for the CSIR Net Physics exam preparation, and by all the top educators, whatever courses are going on, you will be able to attend the live classes for all those courses. So that's how you will get the best guidance, and you will get to know about the best strategy, the approach to solve the questions, which are the important topics, what is going to be the best way to do the preparation, and everything. So if you want to prepare with the Unacademy Plus courses, because these courses will help you a lot to do the best preparation for your upcoming CSIR Net Physics exam, then you can take the Unacademy Plus subscription. Also, by using and by applying the referral code, that is Anjali Arora, you will get the 10% discount in the total Unacademy Plus subscription amount. You just need to write it as it is, no space in between, and the spelling should be same. Okay, and that's how, by writing and by applying it, you will get the 10% discount in the total Unacademy Plus subscription amount. Thank you so much everyone for joining this session. Smriti, all the new courses and the courses which are going on, everything you can check on the Unacademy Learning app. Okay, so you will get to know about everything, the course structure and everything there. Clear? Thank you so much guys for joining this session. Thank you. I hope that the session was helpful for you and everything is clear to you. And tomorrow and day after tomorrow again we are going to have the live session here, clear, at 4 o'clock. So don't miss the sessions.